Hello everyone! The last video was a rousing success, so that means I'm going to be continuing making videos in this format. So, here we go. What I have here is I have a little program on apps.diagram.net. If that's too confusing, draw.io will literally take you, I'll leave the page, will literally take you to apps.diagram.net. Because they changed the name, but draw.io still works. So I'll just go and create a new program here, a blank program. We will be using this program this week to eventually make ourselves some flowcharts that wind up being used for games to simulate a computer code. But before we get there, let's just talk about how computers wind up talking to computers. Because I'm just going to say there's a circle, there's us. And I'll just click there and I'll say that's us. And us is currently, at the time of making this video, Delaware. And I'm going to make another one of us. Oops, let's make another circle. Make another circle. There we go. And I will go and make this, I don't know, California. We're just going to assume that I'm trying to get from my computer in Delaware to a computer in California. Or more specifically, I'd be going server to server. What is a server? A server is basically, let me think of it like this. We're in a university, right? The university has a bunch of rooms. Those rooms all have a bunch of computers in them. So if you want to think of it like this, actually I'll just click and drag. Every single computer in the university is on the same server. So they're all tied together on one big giant thing. So let me just undo there. Undo, by the way, is Control-Z or Command-Z if you're on a Mac. Yes, there will be a quiz question about generalized keyboard commands like save, save as, copy, cut, paste, print, open a document, open a new document, so on and so forth. So, anyway, going from Delaware to California, much like on a highway, is not a one-way street. I can't just simply click and drag and draw an arrow there. So, what there actually is there's other highways, if you want to think of it like that. Or if you want to think of it like your cell phone. Your cell phone isn't a one-way street either. Cell phone line goes, up to, I don't know, some sort of cell tower, and then from the cell tower it goes from the lines across here. That's probably a landline more, but or your television. Your television goes up to a satellite. Satellite bounces off to another satellite, and then that satellite, bounces down elsewhere. There's more than one path, is what I'm trying to say. So, and it's like a highway. So we have ourselves a bunch of different nodes. Okay? And I'll just copy and paste. So Command-C, Command-V, Command-V again, Command-V again, Command-V again, Command-V again. I'm just going to keep making a bunch of different nodes here to demonstrate the point. So much like highways, we have ourselves paths. Paths to go to different places. And much like every driver on a highway, they will generally take the path of least resistance. So if it's fastest to go, down I-95, well, then that means generally every single person on the road is going to take I-95. Why? Because it's fastest. So let's just say that our most direct route to this place is this way. Now that I've got a bunch of different paths made. If we take the center route, so from Delaware to, I don't know, we're going to say that's New York. And then from New York, it takes us to Texas. And then to Texas, we go to California. Boom, 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 boom. I mean, there's other ways we could have gone. We could have gone to Georgia, and then we could have gone to, Florida, and then we could have gone to Nevada. Why not? Envy is Nevada, I believe. It'd be lovely if I screw up all these little codes for the states. Or, we could have gone to Connecticut, which is... Okay, we're going to go to Vermont, because I think Vermont I know. And then we could have gone to, North Dakota. And then we could have gone to Washington to get to California. We could have gone a numerous number of ways to get here. But our most direct route we determined was New York, Texas, California. Well, what happens if, say, the road to New York and Texas is gone? Well, much like how every day that happens when there's a 12-car pileup on I-95, well, traffic diverges. It goes down 495. It goes down 295. It goes and says, oh, I see the giant cluster up ahead. Let me get off this ramp. And that ramp basically is a different node of the server. Your computer, whenever it's acting slow on the internet, it might just mean there's more traffic. And that traffic might be because there's a little node that broke. Maybe Florida just burst into flames and the entire, it got hit by a hurricane. The server, it's gone now. We can't go to Florida. Well, now we have to go through North Dakota. But that means every single transaction out of New York now is going through North Dakota. Do you think the North Dakota server was intended for the entire traffic of New York? Probably not. The North Dakota one is probably a much smaller server. So you've got this gigantic server right here, this big giant New York server, and it's going into this tiny little one. Much like how the 6-lane highway, that is I-95, and then everyone diverts off into a road. A 2-lane road. Was the 2-lane road going to handle the same traffic capacity as the 6-lane highway? Well, yes, but it'll take it at a much slower pace. And that just is why some days you go all the way to wherever it is you're going, and you have to take into consideration that all these arrows actually go the other way back as well. You've got these arrows going back and going back the way they came, so on and so forth, because all these arrows essentially are a two-way street. When I go to a website, I'm not just simply going to California. I'm going to California, and then they're looking at my server, going and saying, yeah, we don't see anything suspicious, we don't detect any viruses or anything. Let's go all the way back and give them permission. So it's actually going to and then going back. You can actually see this sort of situation happening if you have two televisions in two different rooms of a house, and they're watching the same program. One television is always about a second ahead of the other. It just takes a little bit longer for that, information to get from that spot to the next spot. You'll see this at like a Super Bowl party, where one room starts cheering moments before the play even happens on another room. So, one room is always spoiler of like, oh, I guess something exciting's going to happen. Oh, yay, something exciting did happen. Or, wow, something really depressing's going to happen. Oh, yeah, there's the fumble. Yep, they saw that before us. So, that's generally how that goes. Now, in theory, so long as there is a path of some description, maybe that line is dead, maybe that line's dead, that's dead, that's dead, that's dead. As long as there is some line of description of some sort, we will eventually get to our destination. We will eventually, even if it's the most roundabout way. The only time that you will not have something exist is if the end result doesn't exist. If I'm trying to get to Google, and Google itself is down, I can't get to Google. If New York is down, if Texas is down, I guarantee you there is some other way that they will wind up going this way, and then that way, and then that way to get to Washington. There is always some sort of path to take. But if I'm down, if Delaware is down, if my computer is down, Google can't send me information. If Google itself is down, I can't access Google. The two endpoints on the very far extremes of this chart are the 2 points that have to be open, that have to exist. Everything else is in a constant state of flux, but the start point and the end point are the 2 things that must exist. And you'll see that being the case in a lot of line-by-line coding, where if you start something with a parentheses, you will have to end it with a parentheses. If you start something with a tag, I don't know, like there's a paragraph tag, you will have to end it with that paragraph tag at the end. So on and so forth. You know, if I make a print statement, I need to make sure at the end I've told the print statement where to end. If I'm starting with a string, I need to tell it that there's string ends, so on and so forth. When it comes to computers, the data type, it needs to know when something begins and when something ends. And this is generally, in brief oversimplification, how computers talk to other computers. In the next video, we'll be using this sort of concept from this chart, this diagram application, to go over system development life cycles. We're going to start going over actual processes. So, thank you very much, and I'll see you next video.